So what I was just meant, well, good morning, everybody. This is almost our last class. We have one more tomorrow. And what I was just mentioning to everybody is that I'm going to, right now at the beginning of this class, mention what you need to know for the final. Basically every chapter is on your final. There are a couple of things that we skipped earlier back in chapter or unit 1. And there's a lot of what we're going to skip in chapter 4. So let's talk about chapter 4 first. Basically in chapter 4, we started at page 6. Okay, so in chapter 4, we started here at Introduction to Trigonometry. So for chapter 4, you need to know Introduction to Trigonometry, so page 6, okay? And we're going to finish on page 24. So pages 6 to 24. And again, a lot of this is just practice problems. So right here. Oh, sorry, hold on. I'm not writing. Give me 1 second. Tools. Get my pen going. This is your exam cutoff. So topics. So in unit 4, it's page 6 to 24. So it's not a lot of pages actually considering. And you'll notice on the bottom of page 24, you don't have to do this. So we will do every topic from chapters 1, 2, 3, and 4, except topic 10. In unit 1. And that's it. Everything else is on the exam. So if you think about it, if you're studying chapters 1, 2, 3, and 4, every topic except unit 10, topic 10. We didn't do that. And you can see that in the notes. We didn't do topic 10 and then cut off to this page 24 in chapter 4. All right. So I had that question late last night, and I told the student I would mention it today.
So just for practice 6?
Sorry? Oh, yeah. Just to practice 6. Yeah. So on page 24, it starts a new topic. We're not doing the new topic. Okay.
Sam?
Yes.
Also, page 34 till 36 in unit 3.
Okay, sure. Yeah. I mean, there's so many little things we probably skipped, but yeah, I mean, that's the best I can give you. I mean, I would look at your old tests. We might have skipped a few pages here or there. I didn't keep track of every page, but yeah, the basic thing is basically all of the first 3 units we skipped except topic 10, and there's a few pages we didn't do for sure. So let's get started with this section. So yesterday we finished here on page 11. Now you might be thinking, wow, we got like 13 pages to do, but remember, a lot of these are just a practice. So there's a lot of room for you guys to practice in these pages. And I think you guys are gonna like page 12. This is a really easy one. Page 12 is, I'm gonna show you now. So, okay, let's go back for 1 second. I showed you yesterday how to find these ratios. Oh, and I mentioned we were going to finish practice number 2 on page 11, so we can do that as well. It's not letting me erase. So, oh, this is not good. How am I going to do this? I'm just trying to erase this so I get room, but my eraser doesn't really work. Hold on. I'll get this erased. So yesterday we were talking about sine, cosine, tangent. We were talking about cosecant, secant, and cotangent. And we looked at finding the trigonometric ratios. So what I'm going to show you in a minute, once I get this example done, this is about as good as I can get. I'll write it in blue so it'll really stand out. What I'm going to show you in a minute is after we have done these ratios, how do we find the angle, right? We haven't talked about calculating the actual angle, like 20 degrees, 50 degrees, 60 degrees. In order to do that, you do need to start with the ratios. So remember our phrase yesterday, so, ka, toa, sine. I'm gonna have to write a little small here. So sine is the opposite over the hypotenuse. Okay, now I don't know the hypotenuse. By the way, the 6 here is the adjacent. I don't know the hypotenuse. I'm going to have to solve it. So solving the hypotenuse is pretty easy. We know that the hypotenuse, they call it r, is the square root of each side squared. So 6 squared plus negative 10 squared. I'm trying to write small. It's really hard. So first things first, I'm going to find the length of my hypotenuse. So it's the square root of 6 squared plus 10 squared, or negative 10 squared, same thing. And I will get 2 root 34. Now, I had a student yesterday mention, they were giving me the answer in decimals. This question says find the exact values. We're going to look at what you do with the decimals in the next section. Okay, so sine is the opposite, negative 10 over the adjacent 2 root 34. Now I can reduce this if I wanted to. I could say negative 5 over root 34. Okay, it doesn't ask you to reduce it, but we typically reduce in math. So there's my reduced version. I'm gonna have to zoom in a bit. Okay, if I zoom in, I can write a little smaller, but then this happens. Cosine, ka, C-A-H, is my adjacent, so it's going to be 6 over 2 root 34, which I can simplify to 3 over root 34. Okay, tangent, let me get rid of this line here. Sorry for the mess. Tangent is my favorite. It's OA, opposite, negative 10, over adjacent, which is 6, which I can simplify there to be a negative 5 over 3. Okay, now I'm going to flip them all and get the other angles. Cosecant is the inverse of sine. I got to make sure I'm recording. Yes, okay, good. So all I do is flip sine and I'll get my answer. Secant is the inverse of cosine. So I flip that one and I get that answer. And cotangent, my favorite, it's the opposite of tangent, which would be 3 over negative 5. And there we go. We're going to put all this to practice today. Don't worry. So we're building towards something. You'll see. Again, this will make a lot more sense once I get to these problems here. Now, these problems are very simple. And what I'm going to, sorry, I scrolled down too far. I'm going to show you how to use a calculator to find these things. Now, one thing you need to do, you need to make sure before you do this is your calculator must be in degree mode. Now, what is degree mode? There's 2 types of modes typically for trigonometry on your calculator. There's radian mode and degree mode. Radian, if we could go a bit further, we're kind of out of time, unfortunately, but that's okay. Less things for you guys to study. Radian mode, they use in mathematics, sometimes in physics. We're sticking with degree mode. Degree mode will be primarily what you guys will use in engineering and physics courses. So what I can explain to you how to do this, but what I recommend is on your final exam, so Sunday, if you're nervous, show your calculator to a math instructor. There'll be a bunch of us in there. I'll be in there. And show your calculator to a math instructor to make sure it's in degree mode. Okay, so how do you guys do it on your I can only explain this for a Casio. If you have a different brand of calculator, if it's not Casio, just show it to me in the exam room, show it to another math instructor, they'll make sure. But if you have a Casio, what you need to do is, let me bring up a picture of the Casio. And I'll show you. Give me 1 second here. Large. Hold on, just make sure I got a good picture. Yeah. Oh, yeah. This is the one I liked from the other day. Okay. So what you need to do to make sure it's in degree mode. Well, first, if your calculator has a D right here, this is already in degree mode. If there is no D, if you don't see the letter D, you are not in degree mode, which means you have to set up your calculator. So what you would do to put in degree mode, you would press
Shift and the mode.
Yep, Shift, Mode. I'll show you where these buttons are, and then you would press the number 3. So you would press Shift, then Mode, Shift, Mode. And on your screen, you're going to see like a bunch of numbers, like it'll say 1, Math 10, or Math IO, 2, Line IO, 3, Degree, 4, Radians. If you press 3, it will turn itself into degree mode. So if you press Shift Mode 3, Shift Mode, and then the number 3, you will get degree mode. If you cannot do this, if you're nervous, because I'll tell you, if it's not in degree mode, every answer you do will be wrong. Well, not on the whole exam, but every question you do from chapter 4 will be wrong if you're not in degree mode. Okay, so be very, very careful. Shift Mode 3. I'll move on, but if you are nervous, if you're writing your final, and there's going to be like 170 students, but put up your hand and just check with your instructor. Okay, make sure it's in degree mode. So you should see, if you can see my pen there, I'll do it in red, a red circle. This has to have the letter D. If there is no letter D, or if it's like the letter R, Shift Mode 3, Shift Mode 3. Okay. So back to the notes. Once your calculator is in Shift Mode 3, you can easily do these examples. This is easy. All you need to do on your calculator is put this into your calculator. So what I'm going to do is I'm going to press, sorry, let me just go back for 1 second. I have on my calculator these buttons. You'll notice that there's no cosecant, secant, or tangent, but we don't need them. There's sine, cosine, and tangent. So in order to put this in on your calculator, you just press the buttons and enter the numbers, just like when you put in logarithms. So back to my notes. I would do this on my calculator. I encourage you guys, if you have your calculator right now, to try this. I'm going to press cosine 69.18 and I'll get 0.355. Oh, it says 4 decimal places. So 0.3554. Okay, what about the next one? Sine 42.62. It's going to give me 0.6771. And tangent 86.6 will give me a big, tangent's typically a bigger number, 16.8319. That's it. That's it. Just put it into your calculator, no problem. Okay, so why don't you guys take a minute? Like, you literally only need a minute. If you don't have a calculator, you can't do this. Like, there's no way to do this in your head, not that I know of, or not that I can do. But why don't you guys try A, B, and B, A, B, and C, and we'll check your answers. And then I'm going to show you really what we need to know, which is this right here. So yeah, to just take 1 minute, I'll be back. You can put your answers in the chat if you want. 4 decimal places. I'll just give you another minute for this. Again, I don't see any answers, but like you literally, if you have your calculator in front of you, just press sine 39.8 equals tan 12.67 equals. So just take 1 more minute, and I'm going to move on quickly from this because really the next part is the most important part. All right, let's look at the answers to this. Sorry. Okay, so sine 39.8 is 0.6401. I think it was Dustin in the chat there who put the answers. Let me just see. Yeah, okay, and Dustin, it looks good to me. So tangent 12.62. 0.2238, you could say 39 with rounding. I'm not too concerned about rounding, guys. I am the one marking your exam, by the way. I'm not marking everybody's, I'm only marking yours, but I'm not too concerned about rounding. But I will, if it does say 4 decimal places, give me 4 decimal places. Don't give me 1. You won't get a 0, but you won't get full marks. Okay, that's easy, right? There's really no point to that part. Well, I mean, in physics and later in this chapter or other math courses, you might have used this, but that's very quick. I'm just going to kind of skip through that because this is the big one. This practice prop or this example will lead us into 2 very important examples today. An example like this one, wink, wink, you might need to know. And then there's lots of practice on this, and then a word problem. So something like this, wink, wink, you need to know. And if I can get through 2 of these examples, then there's literally only 1 thing left in this entire course, and it's super quick. So let's do this part. We need to know how to find the angle from the ratio. Now, let me just zoom up for a second. What do I mean? I want you to find theta, the angle. Okay, so what this says, sine theta equals 0.42. And yesterday, I can't remember who it was. It might have been Abdullah or Nasser or somebody else. They were giving answers in decimal form. Well, this is where you would do that. If I wanted to find theta here, I would use this number, but I could put it as a decimal. You could just put this number in your calculator, of course, but you could also use a decimal. So again, what I'm saying is if I asked you to solve this, find theta, you would do what I'm going to show you now, and you can use a decimal for that. All right, so how do we do it? Easy. Just like logarithms.
Sine inverse?
Yes, exactly. Sine inverse. Just like logarithms, there's a shift function on your calculator that will solve the reverse of this. So in order to solve theta, I need to get the sign away. So what I end up mathematically, I'm going to erase this. You don't need to know this, but mathematically what I'm going to do is take the sine inverse of both sides. And again, I'll show you this in a second. It's really easy. And what that means is theta will be this number, whatever it is. I haven't calculated it yet. So what I mean to say is, quite simply, if you need to solve for, and I'm going to write this down, don't worry. I am erasing this because you don't need to show me that step. If I want to solve for theta, I'm going to take the sine inverse of 0.42. If I'm going to solve for B, I'm going to take the cosine inverse of 0.29. And if I'm going to solve for C, I'm going to take the tan inverse of 0.91. Now, how do you do that? What's an inverse? Well, luckily, I have my calculator open. To get the inverse on your calculator, you would press Shift, then the sign button. And that's it. So if I wanted to solve, like, let's just say I wanted to solve sine theta equals 0. Let's just say, let's say 5.5. What I would do on my calculator is need to enter this. So what I would do is I would press Shift, then I would press sine, then I would press 0.5, put in 0.5, and then I would press equals, and that's it. So to solve for the angle, you take the inverse of that function, or trigonometric ratio, we could say. So for sine, you go second function sine, or sorry, shift sine. On other calculators, it might say second function. It's all the same. All right, so let's do it. Let's look at the answers here, and then I'm going to get you guys to practice, and then we're going to do some really wink, wink, wink important problems. The reason I want you guys to try a couple of these is because I want to see if your calculators are in degree mode. So how are you going to know that? Well, try this one with me. I'm going to press Shift Sine 0.42 and hit equals, and I will get the angle of, it says 2 decimal places, 24.83 degrees. Done. That's it. That's all I need to do. Okay, so what about cosine? Well, shift cosine 0.29. I get 73.14 degrees. The unit or the symbol for degrees, by the way, is this little circle up here. Like if you think about it, you guys should know this because of temperature, degrees Celsius. Now, temperature is not the same as an angle, not even close. They're not even remotely related. But if today in Qatar, I don't know what it is. Well, my computer says it's in Fahrenheit. My computer is American. I've got it from Amazon. But let's just say today it's 43 degrees Celsius. So that little circle, I think sometimes they call it a knot. The circle here is a degree. I don't really care if you put it in or not, between us. Okay, anyways, 0.91 is 42 0.30 degrees. Ooh, that's a weird looking 3. Okay. Now, guys, you don't need to do all 6 of these. I mean, what's the point? They're all going to give you similar numbers. Just try a couple of these. You know, why don't you just try A, B, and C? And the reason I really want you guys to try this is because we can see if your calculator is in degree mode. If your calculator is in radian mode, you will not get the answers that I got above. So if you're doing A, B, and C above and you get something different than what I got, your calculator is in the wrong mode. This is the only time in math where your calculator can hurt you. Your calculator is amazing. Just make sure it's in degree mode. All right, I'm going to stop talking. I'll give you a minute or two. Just do the top 3, and then we'll check your answers and move on. All right. Amar is giving me some answers here. Well, let me just see. Amar, I haven't done this myself. I'm just kind of sitting here patiently. Yeah, you're correct. So Amar in the chat, you have A and B done perfectly, which means your calculator is in degree mode and you know what to do. There's no magic way to see if, well, sorry. There's no way to look at the number really to see if you're in degree mode. You just need to look for that little symbol on the calculator, that little tiny D on the very top. Don't worry about anything else up at the top. As long as that D is there, you're good. All right. Let's get these out of the way. I mean, again, this is everything I've showed you is leading up to the next 2 types of questions. So this is actually a very important class, even though it is near the end of the semester. But this is just kind of like a step in a bigger question. I'm secretly very excited for the next question because I love what's coming up is one of my favorite types of math questions. And you will use it in other courses like physics as well. Anyways, so the inverse cosine of 0.42, we're looking at what Amar said, 65.17 technically, but again, if you said 1.6, I don't care. Tangent 0.29. If it wasn't like intercession and we had a bit more time, I probably would care. But you know, this was a crazy time. You gotta add in COVID, Ramadan, Eid, and intercession, and think about all of these factors when you're thinking about this course. So you know, I'll go easy on you guys, I promise. Oh, I guess I should write my working, shouldn't I? Hold on, let me write down what I did. So I did tan inverse of 0.29, you'll get 16.17. And then the last one, sine inverse of 0.91, 65.51. Now, again, like my guys, so my calculator is saying 65.505, but I want 2 decimal places. So I'm going to sorry, that's a 5. I'm going to round up. Again, I'm not too concerned about that. If you like, what I mean is if you said 65.50, that's fine. Which is what Amar just said, which is perfect. I don't care. That's perfect. I think, you know, a hard math instructor might be mad at that, but I don't, it's okay, really. It'd be different if you were an engineer and like think about this. If you're an engineer and people's lives are at stake, you know, you're working on machinery, heavy equipment, you're working at a refinery, and you're calculating angles where safety is involved, half of a degree can make a difference. But for math, it's okay. Okay, guys, here we go. It's 10:10 or 10:11. If I can get through 2 topics, I'll be happy. I don't know if I'll get through the third, but the third one is very, very quick. These are the big 2. There's 2 questions I'm going to show you now that are at the end of your final exam in some way, shape, or form. So all of this stuff we've been doing about SOHCAHTOA, you know, sine, cosine, tangent, and all this stuff about angles is coming to a resolution. There's a point. In this section, and I'm going to do both of these today. I think you guys will like this. I hope it's kind of fun. In this section, we're going to learn how to just solve a triangle. Okay? And what I mean by solving a triangle is sketching it, labeling it, and then finding all of the unknowns. Now, if you can sketch it in your head, you can go for it. Like you're not being marked on a sketch, but it really helps to draw it. Okay, so that's part 1 of today's big section. Part 2 is the word problems. I love these. I think you guys will like these. They're not hard if you draw a picture. So today we're going to draw a couple pictures. There's a lot of examples here, obviously, and we're going to look at some of these questions. It's really fun. Oh, I think it's fun. And for any of you guys going into physics next semester, or the students here doing the degree program that's coming, this is so important. So let's start with not a word problem, just solving a triangle. It says solve triangle ABC given the following information. Now, one little note. All triangles on the exam are right triangles. So why does that matter? Well, if you have a triangle that has a strange shape like this, or like this, well, that kind of does look like a right triangle, but you get the idea. Like, what now? Boop, boop. I don't know. It's really hard not to draw a right triangle, but you get the weird shaped triangles we're not doing. We're doing right triangles. Now, what is a right triangle? A right triangle has a 90-degree angle. And then you have legs and you have the hypotenuse. So why does it matter? Well, if the triangle isn't a right triangle, everything I've just told you doesn't work. So Pythagorean theorem, that SOHCAHTOA stuff, none of that works for triangles that are not right triangles. If we had more time, we would look at triangles that are not right triangles, but you guys are very, very lucky. We do not have time. So you and all of the other classes are not doing this. We're only looking at right triangles. Now in physics, this is the reason we're doing this is because in physics, this is going to be the big help. You're dealing with a lot of right triangles. Oh, the other thing I'll mention too is the right triangle has a 90-degree angle. Okay, so let's get started. I'll do a couple of examples, get you guys to practice, then we'll look at some word problems. So triangle ABC. First things first, step number 1, I'm going to sketch and label the triangle. I can draw this triangle any way that I want. I am choosing to draw my right triangle like this. Okay, it doesn't matter. You can draw it like this. You can draw it any way you're comfortable. I like to draw mine, and sorry, that was a bit messy. I wonder if I could use, hold on, hold up. I thought there'd be a triangle drawing tool. There is. I can draw lines, but nah, that's too hard. Sorry. I was going to try to draw a triangle for you with the tool. But anyways, I like to draw mine just like this. Okay. I put my right angle right there. Now, let's read the information. First things first is the angle B is going to be my right angle, so 90 degrees. Now, what that means is this angle across from it is little b. Okay, the most important thing you can do is label your triangle correctly. So the 90 degrees, the place where I have the right angle is B. Now, what about A? What about C? Well, it doesn't matter. So I'm going to call this A. I'm going to call this C. The other angles don't matter. B has to be labeled correctly, and then everything else I can just label like this. So remember, the side A is opposite angle A. Okay, side C is opposite angle C. All right, now I can get started. So B is 5 centimeters. A is 2 centimeters. So now I can solve this question. All right, what do I want to do first? Well, I could find angles. You know what I would start with is I would start with finding C. Now, we know that a triangle is the hypotenuse squared equals one leg squared plus another leg squared. So this is going to be 5 squared equals 2 squared plus C squared. I don't know C. C would be my unknown. It could be X, it could be Y, it could be anything. Okay, so, oh man, I'm totally gonna run out of room here. But anyways, C squared is going to be 25 minus 4. So it's, sorry, I'm getting a lot of messages from my colleagues at work. It's gonna be 21. So C is going to be square root 21. Now, you know what? If you want to put that as a decimal, no problem. At this point in this course, you can use decimals here. It doesn't say solving it to any exact number. It actually says solve it to one decimal place. So root 21 is 4.6. Okay, cool. So there's a mark. Now, I'm not done because I also need to find angle A and angle C. So, I wonder if I can get rid of this. Can I? No. Hold on. I just want to see something. No. Oh, no, that worked. Okay, good. That's perfect. Okay. So now I know side C. It's 4.6. So what if I want to find angle A? So I want to find angle A. Well, I'm going to use sine, cosine, or tangent. I can use whatever I want here. I can use whatever I want. Let's just, for example, use sine. So,
Sir,
yes?
but we have the A. Why will we found the A again?
Do I know angle A?
Oh, okay, angle. Okay.
Yep, angle. I'm trying to find angle A. Angle A. So, let me just change my color because this is looking a bit crazy. Okay, so I want to find angle A. What is angle A? Well, here's what I'm going to do. This is capital A, so I'm just going to call it A. What is big A? Not lowercase a, big A. Big A is the angle. Well, I can use sine, cosine, or tangent. I'm going to use sine. Again, it really doesn't matter what I use. Hold on, I'm going to close my notifications here. Quit. Okay, so I'm going to use sine. Again, it doesn't matter. So sine angle A, we write angles with a capital letter, is the opposite angle. So opposite is 2 over the hypotenuse, which is 5. And then I solve. A will be sine inverse 2 over 5. And you can use the decimal there, whatever you want. So sine inverse, second function, sine 2 over 5 gives me 23.6 degrees. All right, what about B? Well, for B, I can use sine again, really, if I want to. Or I could use, sorry, B is solved, not B. B, we know B. B is 90 degrees. It says right here, not B. I'm talking about C. What if I want to find C?
90 plus 23.6. 180 minus the plus.
Yeah. Okay. So I haven't even explained that yet, but that's good. Okay. So what was just said is a really, really smart way to find C. I'm going to show you two quick ways to find angle C. We can find angle C by using, again, we could use sine again. Okay. Oops, sorry. I meant to put a question mark here. So sine C is going to be the opposite of C, which is 4.6, divided by the hypotenuse, which is 5. So C will be sine inverse of 4.6 over 5. I wrote a lot here. It's actually not that much writing. I'm just trying to show you all the steps. Okay, so second function sine 4.6 divided by 5, and I get 66.9. Now, some of you guys might be wondering, why did I use sine both times? I was feeling like it. I could have used cosine. I could have used tangent. You could use any angle. It just means you're going to use different ratios, but you will get the results. Now, I don't know who was speaking. It might have been Abdullah, maybe, but Abdullah had
Abdurrahman.
So Abdul Rahman?
Yes.
Okay, Abdul Rahman came up with an even easier example, and I'm going to have to erase a lot of my writing in a minute, guys, but just a hint. The sum of all sides, or sorry, not sides, angles in a triangle equals 180 degrees. Now, you don't need to know this. This is just Abdul Rahman came up with a really good hint or tip to solve this. So when he wanted to find C, he said, well, it's 180 degrees minus 90 minus 23.6, and you'll get roughly the same answer. The reason the answer is going to be slightly different is because of rounding. So this is 66.4 degrees. Same thing. Well, it's not exactly the same, but the reason they're different is because I rounded 4.6. But because of the rounding error, it doesn't matter. These are both acceptable answers. So very good tip. If you know two of the angles, you can easily find the other. The sum of all angles in a triangle is 180. So C must have been 180. Take away the 90, take away the 23. I'll get my answer. 66, around 66. Again, the number is different because of rounding. All right. Actually, so that hint, we can apply it to example number 2. I'm definitely going to do example number 2 for you. Guys, I'm going to have to clear my screen because I went crazy with writing. Just take a second. Maybe you can take a picture or a screenshot. This will obviously be on YouTube. I'll try to write a little bit neater in the next example instead of going everywhere for this. It's just the book doesn't give me a lot of space. All right, so I'm going to erase this. I'll do one more example. I'm going to ask you guys to practice one or two of these. There's so much practice here. And then I'm going to do word problems, and that'll be
Mr. Mark,
it. Yes.
this is a wink question.
Yep. You see the little winky face here? Little winky man?
Yeah, I just noticed.
Yeah, no, this is definitely a wink wink type of question.
Okay.
Yeah.
So we should look out for this type of question, yeah?
Yep, absolutely.
Okay.
All right. So let me try and be a bit more organized here. I'm going to try to write this a little bit neater, I guess we could say. Oh, this is going to be an interesting one too. Because yeah, I'm excited. Okay. Sorry. This is like my favorite thing. When I was young, I loved trigonometry. Here, let me draw my shape up here so I'll have lots of room to write my answer. Okay. So there's my shape. There's my triangle. You know, it doesn't matter how I draw it. I'm going to move it up a little bit. Okay, so there's my triangle. I want to solve angle XYZ. Now, first things first, the most important angle. This angle Y is 90 degrees. That's you always start at your right triangle. Look at every practice problem, guys. 90, 90, 90, 90, start at 90. So my Y is my 90. The Z and the X, it doesn't matter. It really doesn't matter. So I'm just going to say X, Y, Z, or as a Canadian would say Z. I don't know why. I hate that. Okay. So side Y will be here. Let me pick a different color. So side Y will be here, side Z will be here, and side X will be here. These are lowercase letters. The sides are always opposite the angle. Okay, so, sorry, I got distracted. My question's going crazy. There's a private message in the chat from Amar. Amar said, I guess I shouldn't have said your name. Oops. How do we know that we only have to use sine? I mentioned this earlier. I erased my problem. I erased example number 1. You don't have to use sine. You can use any one you want. You can use tan, cosine, whatever. Maybe in this example, I'll use cosine, right? It really, well, actually in this example, I don't need to use any of them. But
yes, Mr. Mark, does it make a difference?
Makes no difference.
So it's all the same, whether I use cosine or tan or...
Yep.
It's all the same, yeah?
All the same.
Okay.
The difference is like just make sure, like if you're going to use sine, you have to use the opposite over the hypotenuse. If you're going to use cosine, make sure you use the adjacent over the hypotenuse. If you're going to use tangent, make sure you use, opposite over adjacent. The answer you get will be exactly, well, pretty much the same. Like, you know, a decimal place might be changed here or there, but it will be basically the same answer. I just picked sine because that's like my classic, right? You know, but I could have picked cosine. I could have picked tangent. Now, in example number 2, guys, we don't even need to worry about that because, and I can show you this anyways. I can show you another way to do this. Oops, sorry. Clear. Sorry, just changing the color of my pen. I can find my angle X very easily. Angle X will be 180 minus 90 minus 36. And I'm going to get for that, I should be able to do that in my head, but I'm tired, 54. Now that's Abdul Rahman's suggestion. Abdul Rahman said, you know, why don't we just subtract the angles from 180? That works. I will show you how to get this in another way. Okay, now we also know side Z is 9. 9.0. Okay, so Nasser, you have your hand raised?
If I did the same way, like 180 minus 90 minus 36 in the exam, will I get the full marks?
Yes, you will definitely get full marks.
So it's an official step, yeah?
Yeah, there's more than one way to do it, but you can do it this way. It's not an official step. It's just one way to solve this.
So it's all right to use this way. Yeah.
Yes.
Okay.
Okay. So now here's like, just imagine we don't even have that 54. How are we going to find other things? Oh, and I haven't even fully labeled this, by the way. What color? Oh, I'm blue. Let me go back to red here. I also know angle Z is 36. Okay, so now I'm ready to start calculating my other sides. So let's look at, say, maybe we want to find side X, for example. Okay, so think about this. I want to find side X. I have 90, I have 36. So let's use the angle 36 and come up with some ratio where I can find X. Now, angle 36, the X is my adjacent. So I'm going to have to use for this one, and I'll explain this in a second. For this, I'm going to have to use tan 36 equals the opposite, which is 9, over the adjacent, which is X. And this will get me side X. Now, in this case, I had to use tan. Why did I have to use tan? Well, so the angle 36 is the angle I know. The only other angle I know here is the opposite. I do not know the hypotenuse. I'm looking for the adjacent. So I'm going to use tan here. We're going to look at this more in the next section. So I had to use tan here. I was looking for the opposite over the adjacent. If I use sine 36, that would have been 9 over y. That's good, but that's not going to help me for z. So I can use sine to find y. If I use cosine of 36, it would be the adjacent x over y. That's no good. So cosine is useless for me right now because I don't know x or y. So I will actually use sine in a second, but I'm going to use tangent right now to find x. I'm trying to get rid of that dot, but it won't go away. Oh, well. All right. So I cross multiply. X is going to be 9 over tan 36, and you'll get your answer. So so tangent 36, close your brackets, or sorry, 9 divided by tangent 36 and hit equals, and I get 12.4. All right, cool. You could say centimeters because my unit's centimeters. Okay, so I know angle X, I know side X. Let's find Y. So for Y, I can do the same thing. I could use Pythagorean theorem. This is the beauty of these questions. There's so many ways to solve this, but I can also use sine 36 is equal to the opposite, which is 9, over the hypotenuse, which is y. You can definitely use Pythagorean theorem here if you want to. This is, again, the beauty of these questions is there's so many different ways to solve this. So y is going to be 9 over sine 36, and I'll get my answer there. 9 divided by sine 36, and I get 15.3 centimeters. I could also use Pythagorean theorem. Like, this is going to be hard for me to mark on your final exam because there's so many ways for you guys to solve this. Okay. Now, that's it. Like, I'm done. If you didn't know this rule here, you could actually find X in another way. So I could find angle X up here using a trigonometric function. So if I wanted to find angle X, I could, for example, say, any, like you guys pick sine, cosine, tangent, it doesn't matter. I could say cosine x is the adjacent over the hypotenuse. So cosine x is, what's adjacent to x? It's 9. What's the hypotenuse? 15.3. And I could solve x this way. So this should give me around 54. Again, this is, I hope I'm not confusing anybody. All I'm saying is there is multiple ways to solve a triangle. Yeah, I get 53.9. Perfect. There are more than one way to solve this, right? Whatever you're comfortable with. If you want to use Pythagorean theorem, do it. If you want to use this rule that Abdul-Rahman mentioned, 180 minus 90 minus 36, do it. If you want to use tangent, do it. I think that maybe I like these as a student because I could do what I wanted. You know, I had to follow the rules, but you know, maybe I don't like Pythagorean theorem, so I used 2 trigonometric ratios. Personally, I find the trigonometric ratios a little easier than Pythagorean because I'm not dealing with roots and squares, but it's up to you. All right, so why don't you guys practice? You definitely need to practice this. I would love for you, I'm trying to think of the time. I think we're okay for time because after this, I'm going to get you guys to do a couple practice ones. I have one more topic to show you, which of course isn't showing up on my computer. It will show up in a minute. You can see Nasser, there's another wink face whenever this slide decides to show up. Hold on here. Okay, there we go. I might have to reload the document, but anyways, let's just take a few minutes, or I'm going to give you a few minutes to practice this. And then at 10:45, we'll start the word problems, which is exactly the same as this, except it's a little quicker. And then that'll be it for today. So here you go. Here's 2 practice problems. Give this a try. And I'll be back at, you know, maybe 5 minutes or so, see if you guys can solve, at least try practice problem number 1. Okay, so yeah, try practice 1 and 2. I'll be back in a minute. And as to Nasser and everybody else, this is a wink, wink question. If you can do this now, you can do this on your final. So I'll be back in 5 minutes. Good luck. Sorry, sorry for coughing into the mic. These take time, so I will give you some more time to do this, but as long as you can try at least practice one. Yeah, so yeah, take another couple minutes. These do take a little bit of time. And I got an answer from Abdullah in the chat, so he's telling me some answers for angles F and D. Perfect. So yeah, just another couple minutes. We'll look at the answer, and then I got one more thing to show you. So yeah, I'll put myself back on mute, and in a few minutes, we'll look at the answers. All right, that was about 10 minutes, which is pretty long. Let's have a look at the answers. These are hard to type, and maybe some of you are need a couple more examples. One thing I'll mention is if you can do practice 1 and 2, you can do anything really, because they're all the same. All of these are the same. So if you can do practice 1 and 2, you can do any problem. So that highly recommend that. And then I think I'm going to have to restart my program, but the next section is a lot easier than this if you can draw the picture. So the reason this problem is so much work is because we have to solve everything. We have to solve all of the angles, all of the sides. Word problems are not going to be like that. So you'll kind of see the next section is going to be a little bit easier for you, assuming you can draw the picture, which can be challenging. Okay, so let's have a little look at practice number 1. A little disclaimer, everybody. I might not solve. Okay, I'm going to restart my Word. I'm getting all these errors. Just give me 1 second. I'm going to restart Adobe. I'm on page 13. Okay, give me a second here. I'm going to close everything. Nope. Sorry. I don't even remember what I was just about to say. Just hold on, guys. I'm having some computer problems. I went most of the semester with no computer problems, but it was bound to happen. Here we go. Just give me 1 second to open this up. What I was going to say before my computer decided to die is just a disclaimer, I might do this differently than you, but if we get the same answers, it doesn't matter. That's the beauty of this part. I might use Pythagorean theorem. You might use sine, cosine, tangent. Like it's all kind of, up to how you're feeling, I guess. I know that sounds weird, but as long as you're doing it correctly, you're following so, ka, toa, you're using the degree mode and all that, you should be fine. So let me just make a little sketch of my triangle. Okay, I'm giving myself a lot of room here. So little triangle sketch. So here's my triangle. So E is 90 degrees, which means this side is E. That like step number 1, 90 degrees, put across from that angle E or side E. Very important. Now, it really doesn't matter where I put D and F. A, B, C, D, E, F. I'll go this way. But what that means is D is here and F is here. If you put F or D somewhere else, it doesn't matter. All that matters is that your E is in the same place as mine. Everything else, no problem. Okay. Ooh, this is a good one. You guys get a good one. Okay. So remember my formula. There's basically 2 formulas you need to know, this whole SOHCAHTOA business. And that the hypotenuse squared is equal to one of the legs squared plus the other leg squared. So my hypotenuse is E. So E squared is going to equal F squared plus D squared. So E is going to be the square root of 8 squared plus 8.6 squared. And that's it. And we're going to write our we're going to write our answers to 1 decimal place. This is a nice one. This is a good question. Nice and easy to get started with, in my opinion. I get 11 it's almost 11.8. I am going to write 11.7 centimeters. But Mike, it's very close to being 11.8. It's 11.745. 11.7, we're fine. Okay, what about the angles? Oh my gosh, there's like we have like a work chat group on Microsoft Teams, and for all semester, never heard from anybody. And today it's going crazy. So sorry, I just muted it. Sorry about that. Okay. Now, what do I want to find? Do I want to find angle F or angle D? It really doesn't matter. Let me do one thing. Let me put my answers on the triangle so you can see what I'm talking about. So let's see. F is 8.0. D is 8.6. E is 11.7. Okay, let's look at angle D. We'll start up here at angle D. I can use, I think it was, I don't know who mentioned this in the chat. Amar, I think, mentioned this in the chat. How do you know when to use sine, cosine, or tangent? you can use whatever you want. Let's use tangent. Let's find the tangent of D. Tangent of D is opposite over adjacent. Okay, so tan D is going to be the number opposite of D, 8.6, divided by the number adjacent to D, which is 8. 8 means next to. Notice that tan doesn't have the hypotenuse, so I'm not using 11.6. So D is going to equal tan inverse of 8.6 divided by 8. Why did I pick tan? I felt like it. I wanted to pick tan. And I get, so 8.6 over 8. You will get 47.1 degrees. Oops, sorry, I didn't mean to cross that out. What about E? Or sorry, F, F. What about F? I can use tangent for F again. Well, no, okay, let's be different. Let's use cosine. Now, I think a math instructor would probably prefer that you use tangent, but we're not getting into those details. They're all going to give you the same answer. Let's use cosine. Why not? Cosine is the adjacent number to F, that's 8.6, over the hypotenuse, which is 11.7. Now, a warning here, because 11.7 is rounded, my answer won't be perfect, but I'm not looking for perfection. All right, I think Dustin or somebody in the chat had their answers, so I'm going to check mine with yours, and we should be very, very close. We won't be exactly the same, but we should be close. So I get 42.7 degrees. All right, let me check the chat. So Dustin for C got a little bit different than me. I hope I didn't make a mistake. Let me just check E again. If I made a mistake on E, I'll have to fix it, but I think I'm okay. Yeah, 11.7.
My E is 11.74. So my
Yeah.
F is 42.95.
Okay, perfect. What'd you say it was? Sorry, what was your number?
For F or for
Yeah,
E?
for F.
42.95.
Perfect. No problem. Guys, I just had a message from the chat from Mansoor. Mansoor says, what's the error of margin for decimal points? Like plus or minus a degree, I don't care, right? Like if I say 42.7 and somebody said 43.1, that's fine. If you did these questions and you got like 23, that's not right. If you did, if for D you got 85, like that's not correct. And one thing, Dustin in the chat said his answers for practice 2, which I should have noticed because you put a 2 right in front. Okay, let's quickly do practice 2 so we can get this word problem done and then we're finished for today. And my what I said at the beginning still stands. If we can get this done, couple word problems, this is a lot quicker than it sounds. We only have 4 pages left to do and we're done this whole chapter. So we're very, very close. Let me very quickly do practice 2 and then we'll do the word problems. Halas, the word problems are really nice. They're really easy. The only reason I'm doing the word problems today is because I want to have enough time tomorrow to do some review. All right, solve ABC. So C is my 90-degree angle, so it really doesn't matter what A and B are. I'm just going to do this. A and B do not matter where you label them, as long as the angle is across from the side. Okay, so what do we know? Well, let's just get this angle out of the way quick. Angle A, we can easily solve by subtracting the answer from 180. I know that's not in the notes, but that's honestly such a good thing to remember. It will save you so much time if you get a question like this. So 180 minus 78.5 minus 90 is 11.5. That's the easiest way to solve A. There are many different ways you could solve A, but that's the easiest one. All right, what else do we know? Oh, let me write some things down too. So B is 78.5. A is 11.5. The side A is 5.43. All right, so now what I need to do is I need to find angle B and, or sorry, side B and side C. Now, I know all of this information here. Do you see what I'm circling? Let me put it in blue. I know all of this information. So what I can do is I can say that sine, or no, let's do tangent. Yeah, tangent 78.5 equals, now remember what tangent equals, opposite over adjacent, B over 5.43. I picked tangent because I knew the adjacent, but I'm looking for the opposite. So I'm going to solve for B. That would be tan 78.5 times 5.43. So tan 78.5 times 5.43. I'm talking to myself, don't mind me. For B, I get 26.7 centimeters. All right, what about C? Now, for C, I know the adjacent and I'm looking for the hypotenuse. So why don't we use cosine? Cosine of 78.5 equals, by the way, tangent is opposite over adjacent. Cosine is adjacent over hypotenuse. So my adjacent is 5.43. My hypotenuse, I do not know, that's C. So I'm going to cross multiply. Solving for C, I get 5.43 over cosine 78.5. By the way, guys, if you want to find C using Pythagorean theorem, absolutely perfect. Not a problem. You could use Pythagorean theorem here. But I'm just going to multiply, divide 5.43 over cosine 78.5, and I get 27.2. All right, let's check the, not degrees, centimeters. Let's check what Dustin said in the answers. Yep, we got the same, exactly the same thing. So if you notice Dustin's answers in C, we got the same thing. And that's the cool part about trigonometry is, like, Dustin might have done this another way. Mansoor or Amar or Abdullah or whoever's doing these questions, you might have done Pythagorean theorem, but all of our answers should be the same or similar. So guys, every problem under this is the same. You will either get two sides and one angle, or you will get two angles and one side. Every question is the same. So if you can do practice 1 and 2, you can do any of these. Okay, so I'm going to end off here. It's 11 o'clock. So 15 minutes or so, we'll be done. And I know you hear me say that all the time, but really this is going to be quick. We can also look at a bit of this tomorrow as well. We have 2 full hours tomorrow. So any extra things you need, we can look at. The whole point of this, like, imagine, this is such a math question, right? Look at practice problem number 4. Solve the triangle. When in your life is somebody going to ask you to solve a triangle, right? Probably never. Probably only me. I might be the only one that's going to ask you to solve a triangle. But in physics and things like civil engineers or engineers in general, might need to know the angle of elevation or angle of depression of an object. You know, how tall is a mountain? How tall is a skyscraper? What is the angle of elevation from, you know, throwing this ball off of a cliff? A lot of these problems are related to real life examples that is so important for engineers or architects, you know, and like I know your teachers say this all the time, you're going to use this again. This is a real, very interesting and useful topic for engineers. If you're a business or med science student, which I don't think any business students are in here, in business or med science, you'll probably never use this. Maybe X-ray tech might use this for talking about light, but anybody in engineering technology or engineering degree program, you need this. So 2 terms before we get started. You don't have to memorize any terms in this course, obviously, but you should be familiar with 2 phrases: angle of elevation and angle of depression. The angle of elevation, and again, we're going to be talking about real examples here, like the shadow of a tree, the height of a building, the distance of a helicopter from a ground. You know, we're going to look at real examples here. If you see the word angle of elevation means above the horizontal. If you see angle of depression, it means below. Now, think about what that, so like, let me say this again. The angle of elevation is above the observer. So when you look up at a skyscraper, you know, you're down in West Bay and you're looking up at the, you know, the towers there, the Burj Qatar, I think is one of the towers. I don't know, Tornado Tower. There we go. You are the observer, you're looking up. That's an angle of elevation. An angle of depression would be like if you're on a cliff or on top of a mountain and you're looking down. So like, let me give you a little picture. You know, so if this is me in West Bay and here's Tornado Tower, the angle of elevation is me looking upwards. Now, if I'm on top of a mountain and I'm looking, you know, across, the angle of depression is this angle here, like the angle going down. Sorry, I didn't draw that very well, but that's my angle of depression. Elevation means like the height of a mountain if you're talking about geology. So elevation means height, and just think about what depression means in English. You know, if you're feeling depressed, you're feeling down, you're feeling sad. Depressed means down, elevation means up. All right, let's do this. I'm going to do a couple of these problems. We'll be done in 10 minutes because there's a lot of these and you should definitely practice a few of them. So let me show you a couple. A tree has a shadow of 22.8 meters long when the angle of elevation of the sun is 62.6 degrees. How tall is the tree to 1 decimal place? How tall is the tree to 1 decimal place? Okay, so we're going to
So
draw
the up, look the up, look
Sorry?
the up,
Sorry?
to up
Yeah,
elevation.
up. Well, yeah, the sun is up. Elevation means up. Okay, so let's draw a little picture here. I'm going to draw my tree. Actually, I'll show. This is a very Canadian thing to do. I'm going to draw a pine tree. So, you know, here you would have a palm tree or something like that, but here's my tree. And it's casting a shadow 22.8 meters long. The angle of elevation, I'm continuing this because the sun is up here. The angle of elevation, so going up, is 62.6. The question is, how tall is the tree? So guys, I made a right triangle. Isn't that convenient? Right? I made a right triangle and I'm trying to find X. Okay, now let's start thinking about this. Here's my angle. I know the adjacent. I'm looking for the opposite. So O and A. I don't care about the hypotenuse. Who cares? It has nothing to do with this question. So tangent of 62.6 is equal to, remember, so ka toa is equal to x over 22.8. So x is going to be 22.8 times tan of 62.6, and I'm done. Finished. So x is equal to 1427. Oh, sorry. No. I forgot to put my tan in. I'm like, whoa. There's no way that tree is 1,000 meters tall. When I did this on my calculator, I didn't press tan. So 22.8 times tan, 62.6. And I get, there we go. Still a pretty big tree, 43.9. How many? It says 1 decimal place. So this would actually be 44.0 meters. If you said 43.9, I don't care, but this would be 44.0 meters. Very big tree. Very big tree. Okay. Let's look at another. A search and rescue helicopter locates a tanker ship in distress at an 18-degree angle of depression. If the helicopter is flying at an altitude of 750 meters, what is the difference between the helicopter and the tanker? Now, the hard part about these questions is coming up with your picture. So, okay, let's draw a helicopter. There's my helicopter. Really nice helicopter. And it's at a height of 750 meters above the water, above, like, the ground, or in this case, the water. We have a boat far away. I'm not drawing this to scale, obviously, but we have a boat far away. Here's my boat. Okay. And it's at an angle of depression. So an angle of depression, actually, this is a pretty tricky one. An angle of depression of 18 degrees. So here's my horizontal from my helicopter. The angle of depression is 18 degrees. This is a tricky one. You won't see one like this one on the exam. And the only reason, the only reason you wouldn't see one like this one is, can anybody tell me what this angle in here is? So, and this is just like to see if you guys are kind of awake right now. This is a challenging one. So we have 18 degrees. What would this angle be? I need the angle inside the triangle. Would anybody know how to calculate that?
Minus 72.
Yeah. Well, you can. Yeah. Yes, it is 72. Now, how did he get 72? This is a right angle. 90 minus 18 is 72. You won't have to do that on the final. You would be started with this piece of information. So now that you know that it's 72 degrees, again, where do we get that? It's the angle of depression. So the helicopter is looking out across. The angle of depression is 18, which means the remainder would be 72. 90 minus 18. Now that I know 72, this is pretty easy. Okay, so I'm trying to find the distance between the helicopter and the tanker. Well, that's x. I don't care about the hypotenuse. And in a lot of these questions, you won't bother with the hypotenuse. I only care about the distance from the helicopter to the tanker. Oh, no, wait, sorry. I do care about the hypotenuse. Sorry. I'm trying to go quick now to finish before 11:15. The distance between the helicopter and the tanker is the hypotenuse, isn't it? So this is my x. I don't care about this guy down here. I want to find the distance between the helicopter and my tanker. All right. Well, I know my angle. I know the adjacent and I'm looking for the hypotenuse. Okay, so think about that. I know the adjacent, I'm looking for the hypotenuse. So cosine I'm going to use of 72 equals the adjacent side, 750, over the hypotenuse h. And solve for, oh, sorry, we're calling that x. Solve for x and you're done. So x will be 750 over cosine 72. And that's your answer. 750 divided by cosine 72. And I'm going to get a big distance here. But remember, we're like at sea. We're flying helicopters. I'm going to get 2427 meters. So let's just leave it at that. So about 2.5 kilometers away, pretty far. All right, that was a tough one only because I needed to do a little bit of math to find the remaining angle. All right, it is 1:14. I think I'm going to finish. Let's just do very quickly number 3. And then for you guys tonight, if you're bored, I know you guys got a lot of work to do. Maybe tonight you could try example 4 and 5. We'll look at the answers tomorrow, but let me do number 3 and then halas. A straight 120-meter ramp is built down a hillside that makes an angle of 54 degrees with the horizontal. This one isn't really worded very clearly, but I can kind of explain it. So, okay, we have like a hillside and we're building a ramp down the hillside. So, you know, we're trying to get up a hill. And the question is, find the height of the hill. Let me draw that again. That was a messy drawing. Instead of a hill, I'm going to draw it like a cliff or something. So like, here's my hill. It's a cliff. All right. So this is my hill. My ramp is going to try to get me up the hill. If you don't know the term ramp, by the way, ramp is like, you know, like something to help you get over a hill or a bump. So I'm going to draw my ramp like this. The ramp obviously touches the ground below. Okay, so, you know, if you were driving a car, you could move it up the ramp. That's what a ramp is. Now, if you'll notice, I'm creating a right triangle here. So this is my ramp. The ramp is 120 meters. I don't know why I drew that line. Hold on, let me get rid of that line. Hold on, there we go, sorry. Just want to get rid of that line. So my ramp is 120 meters long. The angle it makes with the horizontal is 54. The horizontal being the flat part. I'm sorry that that's hard to see. It's 54 degrees. And I'm trying to find the height of the hill. Now, this is a good problem. This is an easy one, right? We don't have to do any hard calculations. I'm just going to try and find x. So my angle 54. I know the hypotenuse, and I'm looking for the opposite. So, why am I picking sine? I know the hypotenuse. I'm looking for the opposite. Oh, sorry. So I'm going to pick sine of 54 equals x over 120. X is equal to sine 54 times 120. Halas, finished. Sine 54 times 120 gives me a 97, that's a big hill, 0.1 meter hill. So the hill is 97.1 meters. All right, guys, so that's it for me. We got one more little thing to do and then tomorrow, and then we'll start review. All right, guys, so any questions, let me know. Other than that, we're done for today. I will put this recording up in about, I'll upload it in maybe 10 minutes. Okay? Thanks, everybody.